Alrighty, so today we're going to move on to, again, these section numbers mean absolutely nothing to you. I get that, okay? So section 5.2 is in our old textbook, came right after section 5.1. Section 5.1 was simplifying trig expressions and then solving trig expressions. Section 5.2 is going to be proving trig identities. I say that because next week, Tuesday, 1 week from today, you will be taking the test on sections 5.1 and 5.2. So it will be solving, it will be simplifying, and it will be proving. Okay? All right? So here we go at it. Okay? So if I wanted to prove an algebraic identity like x squared minus 1 divided by x minus 1 minus x squared minus 1 divided by x plus 1, all of that equaling 2. If I wanted to prove that left side truly does equal that right side, okay, what I need to do is I need to work one of the sides until it becomes the other side. And if I get it to be the other side, then I've proven it. If I don't get it to be the other side, then I've disproved it, or I've done something wrong. Okay? But you can only, when you're proving, you can only work one side. Okay? I'll say that again for emphasis. When you're proving something, you only work one side. Now, because you can only work one side, you're going to take the ugliest, scariest, the side that you just want to say, not happening. That's the side that you want to start with. Because the uglier it is, the scarier it is, the more you can do with it. Okay? If I'm looking at this one, I can do a lot of mathematical type stuff with the left side. I can't do a lot with just 2. Okay? There's not much that I can do with just 2. So let's work the left side here. First thing that I would do on this, on this left side is I would factor the x squared minus 1. Both of those factor to be x minus 1, x plus 1. So I can factor that left side. Notice how I'm doing nothing with the 2 because I can only be on one side. Okay? What would we do next? Even easier than making common denominators.
Get rid of the x minus 1 and the x plus 1, and then it's just x plus 1 minus x minus 1.
So like this? I think you guys are both saying the same thing. This?
Yeah.
Oops, I did the wrong one.
Yep.
That? Okay. All right, so then that just leaves me with x plus 1 minus x minus 1. Right? Okay. Now what can we do?
Distribute the sign.
Distribute that negative sign. And then combine like terms, right? We're not really solving an equation. We're just simplifying. Okay? And so then we can simplify. Okay? And 2 equals 2. Okay? That's what we're going to be doing today. Except instead of being it with algebraic type ones, we're going to have trigonometric expressions and equations and all that fun stuff. I am going to be giving you the problem. I am going to be giving you the answer. in order to get full credit for these problems, you have to show me all of that work. We are grading 100% your work. If you skip a step or you do a step in your head, we will take off for it. Okay? If you don't show it, you can't get credit for it. And if you're doing something, you've got to show it. Okay? So if you think it, it's got to be on paper. Okay? No ifs, ands, or buts about it. Because that's what we're grading you on. We're not grading you on the answer because they're going to look like this. Tangent plus cotangent equals secant cosecant. Okay? That's what the problem's going to be like. So one of these sides is going to be the problem. The other side is going to be the answer. So you're either going to take the left side and use all of your identities, use all of your mathematical knowledge, and make it look like the right side, or you're going to do that to the right side to make it look like the left side. Okay? Which one of these sides looks more complicated? Right side? I will tell you, just as a little hint for you, adding or subtracting is always more complicated. Okay? Adding and subtracting is always more complicated, so I'm going to go left on this one, just so you know. Okay? What do you think we can do with tangent plus cotangent? We can rewrite them as
Sine over x over cosine of x.
agree? Okay. Then what?
Oh, you gotta get the denominator the same. So
Common denominator? Okay, what is my common denominator going to be?
cosine sine.
Missing from the first one? What's missing on top from the first one?
It's sine x squared.
Sine? It is not sine x squared yet. We got to show it first. I suppose you could show it as sine x here, or sine squared x there.
I would think that would work, so.
What's missing here? Cosine? I would prefer this step though. I know. Again, I'm judging your work. I need to see it. Okay. Now what?
That turns into 1 over so that
Not yet.
not yet. Okay, would you simplify it then? You can't, because it's addition. Yeah. I don't know. Yeah, no.
Cool.
Sine squared x plus cosine squared x. The next one.
Not yet. We got to show this step first. Okay? Now what does the top become? Now the top becomes 1. Right? Which is that's correct. Which is secant cosecant. Ooh, I can barely get it in. Okay? And then it equals the other side. With me? You have to show all of that work. There's a reason that we've been saying, show all of your work all year long. Okay? It's specifically for this. Okay? Let's try another one. Sine of x times the quantity cotangent of x plus cosine of x tangent of x equals cosine of x plus sine squared of x. I know which side I would choose. I want to hear which side you would choose. In terms of complicated, the side that we are going to work. We'll put it out to a vote. Right-siders. Left-siders. Okay, good. We're all on the same page. Okay? Left side, obviously more complicated. Okay? So, what do we want to do first? You tell me. Convert them first?
Yeah.
Okay. All right. So then we're going to have here sine of x still on the outside. Cotangent is cosine of x over sine of x plus cosine of x sine of x over cosine of x. Okay, I love it. What do you want to do next?
Cross out the cosine.
On these over here?
Yeah.
Okay, cross out those two. So this is still sine of x times cosine of x over sine of x. But now this is just sine of x.
You can't. Now you have to. Yeah.
Distribute? Okay. So if I distribute here now, so I would distribute here and I would distribute there, what do I get? You get cosine of x plus sine squared of x, which is,
Well, don't you just show it's cosine x times sine of x over sine of x, and you just show it crossing off?
did we show it crossing out on the first one?
No,
We
I
show-
thought we have to show everything now.
Yeah, so can't you multiply that?
Sure.
There's nothing to show there.
It's just fun to remember.
I know you are. You can whine all you want.
Now whining.
Oh yeah, you are. Let me go back and rewind the video.
Sure.
Try that one. All right, for you left-siders, okay, secant would become 1 over cosine. Tangent would become sine over cosine. All told, that becomes 1 plus sine over cosine. Correct? Okay? If I multiply that now by cosine over cosine, mathematically, have I changed the value of the fraction? Nope, haven't changed the value of the fraction. Okay? On top, then, I get cosine times 1 plus sine. Agree? On the bottom, I get cosine squared. Cosine squared is the same as one minus sine squared of x. One minus sine squared can be factored into one minus sine. Oops, that's a bad sign. One plus sine. Now what can we do? Cancel out the 1 plus sines, leaving me with cosine over 1 minus sine. Yes?
Where did you get the green cosine x over cosine x?
What is cosine x over cosine x equal to?
1.
It's equal to 1, so I can multiply by that and not change my fraction, right? Okay. Where I got it from is we can't use the right side, but that doesn't mean I can't look at the right side. Okay? And the right side had a cosine on the top. So I'm like, somehow I've got to introduce cosine into my numerator. Only way I can do it is if I multiply by 1. Okay? For you right-siders, I'll go in purple this time. For you right-siders, now same thing, I am going to introduce 1 plus sine over 1 plus sine. Also, still a fraction equal to 1. Okay, still doable. Top then becomes bottom becomes one minus sine squared is cosine squared. Cosine cancels out one of the cosine squareds, leaving me with 1 plus sine of x over cosine of x, which is 1 over cosine of x plus sine of x over cosine of x. 1 plus cosine is secant, 1 over cosine is secant sine over cosine. I don't know why it's giving me blue here all of a sudden. Sine over cosine is tan. Okay. The steps minimum to show that. Try that one. Left side or right side? To the left. Okay. Secant squared minus 1 turns into what? Tangent squared. Okay. Now what? Okay, so this would become sine squared of theta over cosine squared of theta. Then times 1 over sine of theta, right? With my keep change flip. So then this becomes sine of theta over cosine squared of theta. And cosine squared of theta is 1 minus sine squared, yep. If you worked right side, one minus sine squared of theta is cosine squared of theta. I need to introduce a sign on the bottom, so then we would multiply by sine of theta over sine of theta, and that would give me sorry, I blanked on my color. Oops, went too early on that one. Not that anybody's listening anymore anyways.
I am listening.
Thank you. So then this would become tangent all over sine, or tangent squared all over sine, and then tangent becomes